Hello, everybody. I'm Yatin Yordanov, Field Application Engineer in CAD, and today with me is Kobe Olin, who is Chief Business Officer at CADY. So today we're going to talk about their extension, how can it be implemented in our designs, how can it help us. So let's start today's webinar. First of all, let's talk about the agenda. We'll start with our campaigns and activities, CAD points campaigns and activities. I'll present them, our current promos, and what's happening with our PCB Design Club. After that, Kobe will present everything about CADY. So, and in the end, we will have questions. So, if you have any. So starting with our campaigns and products for Altium Designer, right now we have two campaigns. One is our Cyber Month in the left of the screen. It's for perpetual licenses as well as term-based licenses. For the perpetual licenses, if you buy a new or additional license, you will get 25% discount from the price. And also, if you choose to use the Pro subscription, you will have also 25% discount of the Pro subscription as well. So if you have a new colleague or your team is gonna expand in near future, this is the right time to invest in Altium Designer. Also, there is a term-based TBL campaign, which offers 10% discount for 2-year TBL license and 20% discount for the 3-year license. So if you're interested, if you have some kind of a short-term or middle-term project that requires Altium Designer, and you want to use the software for like 1 to 3 years, contact us for a quote. So we will prepare for you and help you to choose what's the best for you. Also, we have the second campaign. The first one ends, by the way, on 15th of December. It started 15th of November, the Cyber Month, and ends in 15th of December, exactly 1 month. So the other campaign is the trading campaign that Altium also is. The campaign is also right now takes place. So it's trading campaign. The idea there is that you can return your old license if you have, for example, version of Altium Designer before or around 2015. You can. It's a good offer. You can return it to Altium, and you can perpetual license if you have one. You can switch for a TBL license, and it will come with 50% discount on the price. And when the time comes for the subscription renewal, after 1 year, you will get this renewal for 50% of the price as well. The campaign is only valid for switch from perpetual license to TBL. So keep that in mind. You can follow all our activities on our Facebook page. We also have dedicated group Altium Bulgaria, where we can try to share the valuable information about the software. The group is named Altium Designer Bulgarian Community. You can see the links for our Facebook page there, down on the left side of the screen. Also, you can follow our website, where you can see all our activities and information about them, our webinars, our PCB Design Club, and so on, our promos, of course. We are also in LinkedIn, and we upload all our content related to Altium Designer as well as Autodesk, because CutPoint is a golden partner of Autodesk in Bulgaria. So everything connected to Altium or Autodesk you can see in our YouTube channel. So if you have any questions, you can contact us on our office email or our personal emails. Most of you probably know my email, yasen@cutpoints.com. Also, on the bottom of the screen, you can see our phones. So if you want, you can call us directly and ask us by the phone. These phone numbers are connected to our mobile phones, so we won't miss your call. About our activities, our current activity is the PCB Design Club. Our next meeting will be on 27th of November in 7 p.m. in our office. Last time more than 30 students came, so I think that that's a great success for our club. Also, it's a success for the PCB design community in Bulgaria. So if you want, you can come, you can join the club. And we have a registration link on our website. So you can also register for the club and take part of it. So now that's all from my side.
Thank you very much, Yasin, for inviting me over here to present. My name is Kobe. I'm the Chief Business Officer with CADY, also in charge of sales. So can you see my screen now?
Yeah, I can see your screen.
Okay, very good. So I'll go through my presentation, and please feel free to ask me any question you may have during the presentation. I'll keep my train of thought. So basically, when you go through the inspection process of your design, you go through the regular process. You start with the electrical schematics. You connect everything in accordance with what's written in the data sheet. And once you're done with that, you go through the manual inspection process. Now this, you may all know, I'm pretty sure that you know that much better than I do. This is a very tedious process, meaning it takes a long time. You need to go over each and every connection. You need to open the data sheets and read through them. And they're pretty boring documents. And you need to make sure that everything is connected, and you make sure that you have the temperatures right. And when it says there, please connect that to pin VCC to a 5-volt connection, you need to make sure that you have a 5-volt voltage source. And once you're done with that, you go through the PCB layout, and then you do a bring up, meaning that you manufacture a prototype, a couple of prototypes, and then you find a mistake. And this is what we call a respin, meaning that then you need to trace back, and in most cases, a lot of mistakes are derived from the electrical schematic. So it wastes you a lot of time and money. And I think the main loss is the time to market, meaning that because of all the iterations here, it takes you a long time to reach the market, because that no one can make sure that you don't have any mistakes. So this is where we come in. We have a system that inspects your design, and it makes sure that everything is connected in accordance with what's written in the component manufacturer's data sheet, meaning that you upload the design to our system, and we verify that the design, that everything in your system is connected according to what's written in the data sheets of the component manufacturers. We don't know what your circuit does, and don't care about that. This is not a simulator. Just make sure that everything is connected right. Once you go through that, so this inspection can take you from a couple of minutes to a couple of hours. And then once you have the inspection report and it's error-free, you go to the PCB layout and to the bring-up. But this, we're able to save you between 1 and 2 bring-ups. So it'll save you a lot of time. And then I'll show you how it's done. I'll give you a live demonstration of that. Any questions? Okay, so let's find how this is done. So what we do, we have an AI-based system, and specifically, it's based on natural language processing. We go through all of the manufactured devices, and we have on our database between 1.5 and 2 million components now. And we scan offline the data sheets, and we read them with our system. Our system can understand what's written in the data sheet. Now, you might know that when you read through a data sheet, might have an instruction connection. It might say that connect this pin to ground, or this pin should not be left floating. It can also say it is common analog practices to connect it to ground and all that. So you have different phrasing for the English. So our system understands the English and converts that into a formal language here. This is what we call the engineering language, because our system can understand what's written there. It can detect exactly what is the connection instruction, and we provide both a macro view and a micro view, meaning that we overview the connection instructions, and we also look about the regulation, whether it's ROS compliant or whether it's the temperature range and all that. So once you load the data files to our system, you need to load the netlist and the bill of material files. And then we do the analysis. Here, we don't apply any AI. We don't learn anything about your design. And once we do the analysis, we delete everything because we maintain a very strict data security protocol. And then after a few hours or a few minutes, depending on the design itself, we issue an error report. And it will detail exactly what's written, the errors which we detected in your schematics. Any questions? Please feel free to ask. Okay, I'll just add here that this database resides on Amazon server, secure server. So we maintain very high data security service. And I'll repeat, we delete all the information, all the client's information immediately after we do the inspection, after we provide the report. So nothing remains on the server or anywhere else. And we don't learn anything from your design. The AI is implemented only on the data sheets and not on your design itself. Okay, so I'll give you an example. Let's say we analyze Texas Instrument data sheet. First of all, we analyze which package do you use, because you can have different packages for the same component itself. Let's say here, pin number 1 is VDD, and here pin number 1 is Sense. So first of all, we detect which package you use. This is based on the information you provide in the data files, meaning either it appears in the netlist or in the bill of materials. So let's say we analyze pin number 1. And here, pin number 1, let's say we're using the DBV or the SOT 2.3. Pin number 1 is VDD in this case. So then our system reads supply voltage connected between 1.5 and 6.5. So we make sure in your design that you're connected in the right range, that you have a right voltage source for that. It also said here, good analog design practice is to connect a 0.1 microfarad ceramic capacitor to this pin. So once you upload the design to our system, and this is just a very simple example, we traverse over your design on pin number 1, and here we find out that it's connected to a 0 ohm resistor, but you forgot the capacitor. So this system will issue a warning. It will say component U2, this is U2. It will say the manufacturer part number. This is the manufacturer part number. It will say here, this is the error family. It will say here connection instruction violation. And specifically, you'll be able to see what the error is. It will say in the report, and I'll show you the report in a few minutes. It will say this pin should be connected to ground via capacitor. So what you need to do is look at the data sheet, make sure that this is what you intended, or perhaps you forgot the capacitor, connect the capacitor, and then re-upload the information again to our system. In which case, if you have connected a capacitor, this error will not appear anymore. Questions? Please feel free to ask. Okay, moving on. We also do a much more sophisticated analysis. Let's say we analyze our voltage distributor. So we go through the data sheet and we find out what the formula would be. This is the formula. So we read the formula, and based on the resistors that you put in that circuit, we will calculate the voltage out. So we will calculate the voltages on the network itself and make sure that everything is connected in accordance with what, because people make a lot of mistakes. Perhaps they changed the resistor later on, and they forgot it has an effect on the voltages that fall on the network components. So we will calculate we will use a formula and calculate the voltages on the network. So here's what you'll see. I'll give you an example. I'll not go through all the errors because later on I can send you all the list of the errors which you can find. We don't find all the errors, but consider the fact this is a SAS-based system. We continue improving that, and almost on a monthly basis, we have additional features all the time. So I'll give an example of a few of the errors that we can find. Let's say here, you name this is what we define as a best practice. And a best practice is not necessarily an error. An error, however, we may point out something that might be an error later on. Let's say you named the network, you called it main underscore reg underscore 3v3. In most cases, a board designer will mean that this network is connected to a 3.3 volts. However, we may calculate that the output voltage is 5 volts. So you might say, okay, this is fine by me, I don't really care. However, we will point out this might be an error because you think that it's connected to a 3.3, but the voltage distributor is connected, generates a 5 volt because of the resistors which you connected. So we will point out this might be a warning. We also issue many other warnings, like let's say you connected an always on or an always off to ground, or an always on to ground. So we may issue that may be an error. You might say we've done that intentionally, but we can point out that you might have made a mistake there. I'll go through the configuration file and also mention all the other errors which we can find. Another thing that we can find is the stability check. If you put in the configuration file, if you want us to point out whether you forgot to designate the test point, we will issue out that we forgot this point, and this could be on various ranges, meaning either you forgot on the power or ground network or on any other network. So you can have the report to be very comprehensive or not. You can choose. So in the year of 2022, we've conducted a very extensive pilot test with over 100 hardware companies. And we found that in over 65% of the boards which we inspected, and I'm talking about boards that were designed by very experienced board designers, not talking about by novice designers. And it turns out everyone is human. Everyone makes mistakes. And we found out critical errors in over 65% of the boards. As mentioned, we have more than 1.5 million components on our database. This is growing on a daily basis because every time you find a component which we don't have in our system, the system goes out, finds out the exact data sheet, parses it into our data sheet, and we have a new component in our database. Any questions before I go to the live demo? I wanted to point out that we provide a free inspection. You can register. This is the page. I'll send you, or Yasin will send you a link later on for the free inspection. You can register for the free inspection, and you can upload the design as complex as you want, and we provide a full feature inspection for this design. Now, this design, you can use it as many times as you like, meaning you can upload the same design as many times as you like. You can insert the errors, and you can check whether we find them or not. However, I must say we don't find all the errors. This is an augmentation of the manual inspection, but we have proven to provide immense value to all our paying customers, among them many defense companies, Intel, Flex, formerly Flextronics, and many other large companies we work with. So this is the system that we have. Once you log in, you register the system, this is what you will see. So first of all, you need to assign a new board. Let's call it whatever. And then, depending on the ECAD software that you use, you upload the netlist files. In this case, this is the ORCAD. The ORCAD generates 3 files that are considered the netlist. This is the PST chip, the PSTX-net, and the PSTX-PRT. So you need to upload all 3 of them together. And then you also need to upload the bill of materials, the BOM. Now, the BOM can be almost in any format. However, we do need to have 2 specific columns. One is the designator, meaning that we need to have the R1, R2, R3, U22, whatever. And we need to have the exact manufacturing part number. It cannot be, you cannot say this is a 0.1 microfarad capacitor. You need to have the exact manufacturing part number because we need to know all the details of that specific component. So you load the bill of materials, and then you do the analysis. The analysis is pretty quick. All the analysis does currently is just to make sure that the files are valid. Now, once you see the screen, this means that the files are valid, and we can support the format. Now you can log off, and within a few hours, up to 24 hours, you will receive an email to your email box saying that the report is ready. So how the report will look like? I'll give you an example of a report. So let's have a look at this. This is one example of what the report that you will be receiving. So first of all, you have all the findings here. So let's go through the first one. First, this is the first finding. It says here in C41, pin number 2, the name of the network is 5 volts. This is the component manufacturer number, and this is the error family. It says here potential capacitor breach. It will say here this is the exact error which we found. It will say this is a 5 volt capacitor connected to this is a 6.3 volt capacitor connected to a 5 volts. In which case, if you have a 50% derating factor, this will be an error. So you can mark here on each and every find. You can mark a other skip if you don't really care. So it's done intentionally. I don't really care about that. So next time you upload the same design, this line will be grayed out. Or you could mark it need to fix. You fix it, and next time you export the netlist and upload the design again, and the reason you need to upload the design again is because, as I mentioned, everything is deleted. Once you provide this report, we do not maintain any of the information on our servers. So if you mark need to fix and you fix it, next time this line will not appear. Now here you see here 2 condensed lines. You see index 2, 3. These are 2 condensed lines. You can open them up. They'll say here invalid passive component connection. It will say here this pin should not be left floating. This means that you forgot it. You left it floating. You forgot to connect it. You mark here you need to fix. You fix it and you upload that again. Any questions? So we also have, I'll go through these errors as well. Here you can see a small I. In some cases, we can detect exactly from the data sheet the exact line why we think this is an error. So if you see a small I here, it will say here exactly from the data sheet, it will say here, must be left floating. You see here in parentheses, data ready, it says here, must be left floating. So if you open up this data sheet, look up over the internet this component, you'll find this line inside here. So there again, you can also mark you need to fix or skip or whatever you want to do. Now we also have here additional features which will be very beneficial to you guys once you do the design itself, looking at the supply chain. For instance, one here that you see here, this is the what we define the high risk component. In this case, we are connected to Mauser and a few other suppliers, and this is not taken from our database, but from their database. In this case, we will say this is an end-of-life component. Now, this is very beneficial for you guys to know once you do the design, not to rely on an end-of-life component, because if you're doing a design for a product that's supposed to be on the market for a couple of years, it will not be a good idea to use this kind of component. So right at this stage of the design stage, you might want to replace this component with a different component because you don't want to use an end-of-life component. The same goes for this component. For instance, this component, this is not an end-of-life. However, according to the suppliers, it will say it will take to deliver this component 113 weeks. Now, 113 weeks is over 2 years. In most cases, designers will say, okay, not going to use this component, need to find a replacement. So this is very beneficial, as I mentioned, because right at this stage, you can already change the component, find a different component, or perhaps you can have it on your own repository. Also here, you can, the same goes here, you can mark it as need to fix and skip, and then you upload the design again. Any questions up till now? You're very silent. Okay, so what we have here is the active component coverage. This is we're very transparent with our customers. We say what we do and what we do not have in our database. In some cases, you might upload a design, in which case we don't have the data sheet of the active component. In some cases, you're using a component which is confidential, which is under an NDA, and we don't have access currently to this data sheet. So it will be marked here unsupported. However, we do provide a lot of value, even if you don't support a component or two. We do commit to supporting at least 70% of the active components on the board. And this is why the analysis may take a couple of hours, because once you upload the design for the first time, if we have less than 70%, the system will go out and seek the missing data sheets, collect them, parse them, and add them to the system, and then do a reanalysis. The second time you upload the design and we have more than 70%, it will take the analysis just a few minutes. So we do provide we do provide the information for you to be able to know exactly which component we support and which we do not. In some cases, if you're using a confidential component, we are able to parse it. You can send us. We do sign an NDA with all of our clients. You can redact the data sheet itself because we don't really care about the component's logics. All we need to know is the component pin connection and some of the surrounding information. So you can remove all the confidential information and just send us the connection information. In which case, we will parse the information to our system, and then you'll have the support to your design. Now, this is the configuration file. And I'll go through the configuration file in a minute. Before that, any questions?
You can write the questions as well in the chat, so if you have any.
Okay. Okay,
continue, and in the end, we will give the time again for some questions.
I will go through the configuration page. Okay, very good. I'll go through the configuration page. So here we have the configuration pages. This is where I mentioned that we can provide both a micro and a macro view of the analysis. You can also implement here what we define as best practices. For instance, let's say you're designing a board for the automotive industry. Now, the automotive industry, all the components need to abide by a very wide temperature range, between -40 and +125. So if you click on this, designating that your board is intended for the automotive industry, we will go through all the data sheets and make sure all of your components abide by this temperature range. If they're not, we'll issue a warning that you might want to replace this component. You selected a resistor that stops working at -1. In which case, this will not fit the military board if you do design for military. Here, you can select the rating factor for the capacitor. The range goes from 30% to 70% according to your preference. And this, once you change anything in this configuration file, you will need to re-upload the design again. It takes only a minute or two. As mentioned, we delete the files. But then we'll do another analysis based on the rating factor which you change. You can change it here, or you can make it 55, 70, whatever. The same goes to the pin connection with the resistance between the ground threshold. Here we selected 1 kilo. This is the default. You can select any number you want. Also, the testability for the test points. If you want us to alert on missing test points, we have 3 options here. Either strict meaning that we'll issue a warning on missing test point on power, ground, and enable unused pins, networks. You can have it on loose, meaning that we'll issue a warning on missing test points on power and ground. Or, of course, you can turn it off if you don't really care about test points. The same goes for naming convention. This is something I mentioned in the presentation, where you have a naming convention. Let's say you have a network name that says 3v3, and this network is connected to a 5 volts, in which case we'll issue a warning. You can select whether you want it on or off. So you can play around with many parameters in this configuration files, and then you select on and off on all of them. You do apply, and then you re-upload the design itself and go over to do an additional inspection, in which case, because this is not the first time, it will take only a couple of minutes, you will receive an email when the report is ready. You can log in, and the email will direct you to the specific report which you want to see. You can also download the report and have it in Excel file for you to share around your company. Any questions? Okay, going over to the last section, the pricing and the business model. So the way we price it is based on the number of designs that you want to purchase annually. This is not based like the Altium system where you sell by seats. We don't care about how many users access the system. We just care about how many designs you want to purchase annually. So we have a pricing page here. So first of all, no one uses this one. This is only one design. But we offer one design for free, so disregard that. Once you do the free analysis and you are convinced that we have something that to offer, we have a lot of value, and the return on investment on our system is extremely high, because once you find one mistake, we can save you 1 or 2 respins. And a respin will cost much more than our system. So we charge $4,000 for 8 board designs annually. You buy a subscription, an annual subscription, This costs $4,000, meaning $800 per design. Now, each and every design, each design you can upload as many times as you like. This is considered only as one design. So if you have one project, you can upload that today, correct all the errors, and then upload that in a couple of months later on. Once you want to do a slight revision, you can upload that under the same name. It will be considered only one design. If you buy a larger package for 10 designs will cost you $7,000, meaning $700 per design. As mentioned, we also offer unlimited number of users. So if you have 10 or 20 or 1 in your design team, it won't change the price. If you have more than 10, let's discuss it with Yasin, and we'll be able to offer you a competitive pricing. Now, Yasin is allowed to provide you discounts. So if you are interested, once you do the free analysis, please feel free to approach Yasin. Perhaps we'll do a quick Zoom meeting and then discuss, and we'll be able to provide you a nice discount. Any questions? Okay, so if you want, please continue your discussion with Yasin. He'll answer any question you may have or forward them to me. And I'll be glad to set a Zoom meeting with every one of you if you want to have another Zoom session to discuss and to learn more about our system.
Yeah, also, after you test the system, you can, we'll share information by email. So if you have any more questions in future, feel free to ask. I will help you with the system, and I have the connection with CADY as well. So we will answer everything. If I don't know something, we will answer as quick as possible. So yeah, thank you, CADY, for the presentation.